Hi, we're going to talk about modeling with logistic functions. What we need to understand for some problems, when you try to describe that the amount starts to grow and it starts to grow more and more rapidly at a certain point, but after a while it's going to start flatten. Here's a simple example. If you put fish in a pond, it's going to start to reproduce. And population is going to start increasing as you get more fish, more reproduction is going on. However, the pond is going to have limited space and limited supply of food, and the growth eventually is going to start slowing down, and it's going to start reaching a value that we call a limiting capacity, which means you cannot have more fish than that particular number. So here's the situation. We have Miguel, who opened a hardware store in 1970. He's got pretty good people skills, great customer service, and etc. So he was able to open more and more stores around the city. And the table below shows that with the number of stores for each particular year. To stay successful, he wanted to not expand beyond the city. So because he wants to be able to oversee the operation. So here's what we want to do here. We want to use this data to describe a logistic model in terms of T, the number of years after 1970, and how many stores did he open in 1994 according to the model that we're going to find, and then we'll find a limiting capacity and interpret that. So what we're going to do is we're going to move on and take a look at this. Well, the first thing that I did was that I went into stat plot. Let me show you. Did into stat plot and I entered the values. So year 0 is 1970, so it's going to be 1 store, and 74 of 2 stores, and I put all these numbers in. So 1988 here corresponds to 18 and 12 stores open. So this is what the graph looks like. Okay, I'm going to show you again here. This is our graph, our points. And what we're going to do next is we're going to create a logistic curve that's going to fit this data. So to do that, we're going to do the following. We're going to exit this. We're going to press Stat. We're going to go to Calc. And we're going to scroll down until we find logistic, right here. Option B, we're going to select that. So for that, we're going to enter list 1, comma, list 2, comma, and we're going to go to variables to immediately have it stored in our y variable in the function y1. Okay, so all that typed in. It's going to take a little bit for the calculator to think. And we're getting our equation. So it's c divided by 1 plus a e to the power of negative bx, and these are our coefficients. I'll come back to it. We're going to go to graph. That's what our graph's going to look like. So you can see it passes pretty closely through almost every point on the graph. Okay, so our equation, this is a little bit different scale. Our equation here that we're getting is going to be y equals, it's going to be 14.79 divided by 1 plus a, which is 25.1, e to the power of negative 0.27 t. Okay, so this is our function. We can use this function to do the work that we need. Okay, so according to the model from part A, the number of stores. So 1994, so if we started in 1970, 1994 would be 24. So we're going to go back here. We're going to go to our graph, and we're going to type in, we're going to actually go for calc, and we're going to look for value, and we're going to type in 24. And for 24, we're going to be in a little bit over 14 stores, so we're going to say 14. Okay, so y at 24 is going to be about 14 stores. So what is the limiting capacity of this model? The limiting capacity of a logistic model is going to be determined by the number on top, and the number of top in 14.78 or 14.79. So approximately 15, right? So what does that mean? I want you to think about this simple idea is if you're going to start opening more and more stores, eventually you are going to max out what, you're going to reach the point when the stores are located conveniently for all clients, and opening more stores is really not going to produce you more money because you have a finite, kind of like, fish in the pond, you have a finite space and there's only so much need for hardware store that is going to be necessary to fill the needs of the city. So for him to open, well, we're going to round, so we rounded it to 15. For him to open more than 15 stores may not be a good idea because he will probably be losing money because every store needs to have people to work there, pay for electricity and other bills, and yet he may not have enough need for another store. So that means that the most number of stores he should open is 15. Okay? And that's how we do it. Hope this helps.